Hello friends, welcome to Sri Jayendra's Ring Zone classes. I am your friend and mentor for coming classes with respect to physics. This is lecture number 2 of a unit electrostatic potential and capacitance. So let's begin with today's class. Today we are going to discuss about the electric potential due to a dipole. In the previous class we have been discussed about what is potential, and then we have discussed about the electric potential due to a point charge. So today let's begin with the electrostatic potential due to a dipole. Let's find it out. Yes, first tell me, do you remember what the dipole is? Are you sure? Are you sure? Yes, if not, then let's look at this. uh, One of the negative charges there, one of the positive charges there, and these two charges are separated by a finite distance. This construction is called as an electric dipole that we have learned in previous class. That means in previous units. Yes, and we define the dipole moment P, that is Q multiplied by A. This is the magnitude of the P, electric dipole moment, and its direction is from negative charge to the positive charge. This is all about the electric dipole. And now we are interested to find out the electrostatic potential due to an electric dipole. So let's look. This is a negative of charge, this is a positive of charge. Their separation is 2a. Their separation is 2a, and I need to find out the electrostatic potential at point P. So if this is a midpoint, this distance is the r from midpoint of the electrostatic dipole to the point P, and the distance is r. So let's find it out. What we can do, I'm sure that you must have gone through this and you might know the formula of this, you might also remember this. Yes, but let's do this very quickly. Let's find it out. What we are going to do is, let's look. Let's say this is r1, this is r, and this is r2. And if this is a theta and this distance would be an a, then I can write like this, that this distances would be an distance from this to this would be an a cos theta. Distance from this to this would be an a cos theta. So what I can write is, my distance r1 would be equals to r minus a cos theta, and distance r2 would be equals to r plus a cos theta. Yes, and I need to find out the electrostatic field or electrostatic potential at point P. So what I need to write down is, it's an k q by r kind of thing. Yes, it's an k plus q by r1 and k q r2, but that charge would be a negative. So I will do the same thing. First, electrostatic potential due to a point charge q on point P. Let's say it is a v1. It's in k q by r1. Next, electric potential due to minus of q. It's an k q by r, but here the charge is negative, so it would be a minus of q. I need to find out the resulting potential. That's why I need to add this, that is v is equals to v1 plus v2. This is k q by r1 minus of k q by r2. Let's take k into q as in common, and the terms remains, that is 1 by r1 minus 1 by r2. So the if I replace the value of r1 and r2, if you remember it, it is r1 is equals to r minus a cos theta, and r2 is equals to r plus a cos theta. So this is the value of r1 and r2. Let's replace it. This is k q into bracket 1 by r minus a cos theta minus of 1 by r plus a cos theta. Now you know that this is a, this is b, this is a minus b, this is a plus b. That will give me an a square minus b square. So here in this case it is an r square minus a square cos square theta, and take an LCM of this. So what I can have is, this result v should be is equals to kq multiplied by 2a cos theta divided by r square minus a square cos square theta. So if I assume that a is very smaller as compared to r, or even a reverse is true, that if I assume that a location where potential is required is very far from or compared to the size of an dipole, then I can neglect the certain terms. It would be an a square, and when a square could be a neglected, a square cos square theta would be always a neglected. So what I can have is, it's an v is equals to k into q multiplied by 2a cos theta divided by r square. Now as we discussed on a very first slide, what is dipole moment p? It's a q into 2a. Now so dipole moment p is equals to q into 2a. So if I replace these things, let's look at this. It's a q into 2a with the help of p. So this is equals to k p cos theta divided by r square. So potential what I can have due to dipole, this is potential due to dipole, I can write like this. It's an k p cos theta divided by r square, that is due to dipole. I hope you are clear with this. Yes, it's a v is equals to kp cos theta by r square. Are you done with this? Are you are you sure? Are you sure? Okay. So let's find it out, the potential due to dipole on the axial axis and on the equatorial axis. So let's find it out. Case 1. Potential due to dipole on the axial position. So what I can write is that this would be the minus q, this would be the plus q. Let's say this would be the separation 2a. This is the midpoint, and from this point, this is point P, this is separation R. You need to find out the potential. What can you do? You need to find out the potential. What all can be done? Yes, what you can do is Vp is equals to Kp cos theta divided by R square. Yes, yes, this angle between dipole moment and the distance. Yes, our diagram was looking something like this. Our diagram was looking like this. Now this point has been shifted to this position only. So in this case cos theta should be equals to 1. In this case cos theta would be equals to 1 because theta is equals to 0 degree. So if I replace this kp into 1 divided by r square, this is potential due to dipole on the axial position. It is a kp by r square. Are you done with this? Are you sure? Are you done? Yes. So this is equals to kp cos theta by r square. Now let's look at the potential due to dipole on the equatorial axis. Potential due to dipole on the equatorial axis. So let's look at this. Let's say this is minus of q, this is plus of q, this is point P, this separation is r, this is distance a, again this is distance a, and you need to find out the potential at point P. You need to find out the potential at point P. Here this theta, yes, it is a 90 degree that I can show. So what can I do? Yes, what I can know is P is equals to Kp cos theta divided by r square. In this case, theta is equals to 90 degree. So this is equals to Kp by r square multiplied by cos of 90 degree, and this cos 90 would be a 0. So potential would be a 0 on the equatorial point or on the equatorial axis On this complete axis, potential due to dipole would be a zero. I hope you are clear with this. Are you sure? Are you sure? Can you do this? Are you? Yes. Let's do a numerical on this. Let's say this is plus 2q, this is minus of 2q. Their separation is 4 centimeter. This is the midpoint, and from this is the point P, and their separation is r. You can assume that r is much greater than 4 centimeter. So this is location P. You have been asked that find out electric potential at point P. You have been asked find out electric potential at point P. Now tell me, which point is it? Is it an axial point or equatorial position? Yes, it is an axial position. So if I write axial position, what I can have is it is a kp cos theta divided by r square, and in the axial position it is a k multiplied by p divided by r square, because it is a theta would be equals to 0 degree. So if I replace the value of p, it is a k multiplied by the charge, it's a 2q multiplied by 4, but it is in centimeter, so I need to write as in 4 divided by 100 divided by r square. So this should be is equals to 4 to the 8 multiplied by k multiplied by q divided by 100 multiplied by r square. Now according to the options given, you can evaluate this. If k would not be there, you can replace either by 9 into 10 to the power 9, or either by 1 upon 4 pi epsilon naught, whatever the requirement according to the options given. But can you do this? Are you sure? Can you? Will you be able to solve? Are you sure? Are you sure with this? Okay, let's look at the next question. Suppose you've been given the data as that this is the dipole, this is minus 2q, this is plus 2q, this is point P, their separation is r, and this complete is 4 centimeter. This complete is 4 centimeter. You've been asked that find out electric potential at point P. Now what can you do? Which point is it? Yes, it is an equatorial position, and when you need a potential due to dipole at an equatorial position, you know it must be a zero. Why? Let's look. It's a kp cos theta divided by r square. It's a kp cos theta divided by r square. Now in this case, theta would be a 90 degree. It's a cos of 90 degree, and when it is a cos 90, nothing matters, it's on zero. So potential at an equatorial position will be always a zero. So have you done with this? Are you sure? Are you sure? Any problem? No? Any queries? Yes. Let's move on to the next question. Let's say one of the dipole is there. This is minus q, this is plus q, their separation is 2a. And what you need to do is that, let's say a certain location A is here from the midpoint, it is at r distance away, and another location is point B, even this is r distance away, even this is r distance away from the midpoint. You have been asked that find out work done required to move a unit positive taste charge from position B to position A. This is what they have asked, that find out the work done required to move a unit positive taste charge from position B to position A. Now tell me, what can you do? How can you find out the work done? How can I do this? Any idea in your mind that I should begin with this? Anything? Anything in your mind? How can we do this? How can I do this? No? Okay. Do you remember the definition of a potential? Or rather, it would be a definition of a potential difference. What was it? What was it? What is the definition of potential difference? Yes, it is the work done required to move a unit positive taste charge from one potential to another potential, and we used to say it as an dv is equals to work done by charge. So from this, can I write like this? Work done is equals to dv multiplied by q. And if I can write like this, I am also entitled to write as an v final minus v initial multiplied by charge q. That this is the work done. Work done is equals to v final minus v initial multiplied by q. So if I write this, what I can have is, let's look, that this would be the minus q, this would be the plus q. At this point it is a location A, at this point it is a location B. You need to transfer, this is R, even this is R. Yes, you need to transfer a unit positive charge from point B to A. Yes, yes, from position B to A. So what I need to do is, first I need to write down the potential at B. Now potential at B is at a which position? B is at which position? Yes, you are right, it is an equatorial position. If it is at an equatorial position, potential would be a 0. So that's it. And potential at A, potential at A, what it would be? What it would be? Yes, it is a kp cos theta divided by r square. In this case theta would be a 0, so if theta would be a 0, it should be an kp by r square. Yes, because cos theta would be a 1 and theta would be a 0 degree. Yes, so now if I know this, I can find out the work done. It is q multiplied by v final minus of v initial. So this is equals to q multiplied by v final, it's a k p by r square minus of 0. So this is equals to k into p multiplied by q divided by r square. This is the work done required. To move a unit positive test charge from location B to location A. I hope these things are clear to you. Is it? Is it clear to you? Are you sure? Okay. So I hope electric potential due to a dipole is clear to you, and we can move to the next task. So let's move to that. Now I need to find out the potential due to charged ring. I need to find out that what would be the potential due to charge ring, and let's look at that. How could I do this? Let's begin with this. So this is case 1, and I need to find out the potential due to charge ring at its center at this point. So as you can see that I have taken a ring, and the ring has been charged by a charge of Q, and I need to find out the potential. So what I can do is, first let's take a shorter element and give a symbol as an dq, and let's find out the potential due to that element only. So their separation would be the same. So if I write as a dv, it is a if I write as a dv, it is a k dq divided by r. Now I need to find out potential due to not only this element but due to the charge on the overall ring. So if I integrate this, what I can have is it's in kq by r. What I can have is at center the potential due to charged ring is kq by r. Are you done with this? This, are you sure? Are you sure? Okay. So potential due to charge ring at its center is kq by r. Now let's find it out the next. I need to find out potential due to charge ring at this point. This is at point P, and this point on the axis of the ring. This point is on the axis of the ring. So what can I do? I know that a charge q is given and the ring is having a radius of r. I need to find out the potential at this point. If I find out the distance, it's yes, you know it's in Pythagoras, and according to the Pythagoras, the value of an hypotenuse, yes, this is r, this is x, and their hypotenuse would be given as under root of r square plus x square. So need to find out if I need to find out the potential at point P due to charge ring, what I can write is it's in kq divided by under root of r square plus x square. Yes, it's in Vp is equals to kq under root of r square plus x square. Are you sure with this? Are you? Are you? Are you sure? Okay. So can we go on the numericals of this? Can we? Yes. So let's begin then. Suppose you have been given a charged ring, and this charge is q. This is radius r. This is, let's say, 3r. Now what you require is, let's say this is location number 1, this is location number 2, and you have been asked that find out potential at point 1 and point 2 due to charged ring. You need to find out potential at point 1 and point 2 due to charge ring. Do you remember the formula? Are you? Can you do this? Yes, I'm sure. You must do this. V1. What it would be? It would be a KQ by R. Yes, simply it is over. Yes. Now, what would be the next? It's in V2. So, the distance, this distance would be equals to root of 3R whole square plus R square. This is the distance from the charge ring to the point 2. So this is equals to KQ divide by root of R square plus X square. So this is R square plus 9R square. So that would be is equals to KQ divide by root of 10 into R square. So if I take this as out of the square, it's a KQ. It's a R multiplied by root of 10 volt. What was your answer? What was your answer? Is it same? Is it? Are you sure? Great work. So let's find it out. Something very interesting on the same concept. Suppose a charged ring is given, and as you know, it is positively charged. This is positively charged. This is its radius r. This is separation x. Let's say this is location A, this is location B. Now what you need to find it out, that find out work done required to move a positive unit test charge Q from from point A to point B. Yes, you need to find out this. You need to find out the work done required to move a positive unit test charge from point A to point B. Now you must know the situation of this, because we have already done this kind of questions in dipole as well. So what can you do? Now you will teach me what should I do. Tell me. Yes, you assume it correctly that I need to go with this work done is equals to Q multiplied by delta V, and that delta V would be equals to V final minus of V initial. So if I need to write down this, my V final, from where to where I need to shift? I need to shift it from point A to point B. So potential at point B, that would be KQ by R, and potential at A, that would be is equals to KQ divide by root of R square plus X square. So if I need to find out the work done, what I can do is it is Q multiplied by V final, point A to point B. So finally it is at point B, minus of potential at point A. So this would be is equals to, this would be Q multiplied by potential at B. It is KQ by R minus of potential at A. This is KQ divided by root of R square plus X square. This Q multiplied by KQ by R minus of KQ divide by root of R square plus X square joule. this would be your answer. Yes, this would be your answer. This is the final answer. Can you do this? Can you? Are you sure? Can you do this? Are you sure for this? Will you be able to do this? Yes. Shall I add something to this question? Shall I? So if they have been asked that find out change in the kinetic energy when charge q has been transferred from where to where? Point A to point B. Let's redraw let's redraw the diagram. This is having plus charge. This is its radius. This is the location. Yes, now what is A, which is A and which is B? Yes, A is at the axis and B is at the center. So what I need to find out, I need to find out the change in the kinetic energy. So what I can know is that work done is equals to Q multiplied by from point A to point B. So this is at point B minus at point A. Now if you have remembered the work energy theorem of unit 5 class 11 work power energy, what is it? Yes, it's an work done is equals to change in kinetic energy. Even if you wish, you could write like this, it's an half mv square minus of half mu square, and the rest of the things you know that this is equals to q multiplied by vb, that potential at b it would be a kq by r minus of potential at a, and that would be equals to kq by root of x square plus r square. So this all stuff you must know, but only the new thing is this, and you can use it when w is there. You can use it when w stands for work done. Yes, so when work done is there, you can do this, and this seems very interesting because what they can do is they can simply give you the data. That means the value of x is this, value of r is this, and let's say charge q having an velocity of this much meter per second at location a, and now it has been shifted to a location b. What would be its velocity? Let's say if they have given a mass of that charge, it would be a, let's say, 1 gram. So a very good conceptual question could be created with this concept. So you must remember the master formula. Master formula is this: work done is equals to q multiplied by delta v, and from the work done you can derive the rest of the thing, because work done is equals to change in kinetic energy, and even from the work done you can have a force into displacement kind of thing. So work done can be force into displacement, work done can be equals to q into delta v. So are you done with this? Will you be able to solve this kind of questions? Are you sure? Are you sure? Let's do something new. Next, let's say this ring have been given a charge q, and another ring is there, even this is having a charge q. Radius of this is r, even this is having a radius of r, and their center to center separation Center to center separation is x. Now, now this is location A and this is location B. Now you have been asked that find out find out work done to transfer a positive charge Q from B to A. Yes. How will you do this? How will you do this? And what would be the steps to be taken to do this? What are the steps? Yes, yes. I hope you assume it correctly that it would be W is equals to Q multiplied by from B to A. Finally, it is at A. Initially, it is at a B. So VA minus VB. So you have two major tasks. A first task, you need to find out the VA. How can you do this? What would be the potential at A? Now you must know this that potential at A will be due to two charges. Due to this charges, if this is let's say first charge and this is second charge. That at point A you have a potential due to this two. First due to this charge, a charge number 1, and second due to this charge, a charge number 2. For charge number 1 point A it is at the center, but for point 2 a point for charge 2 point A it is at on the axis of the ring. So what you need to write it down is you need to write down VA due to this charge. What it would be, it's a KQ by R plus plus. Now due to this charge, even it is the same in magnitude but the positions are different. So if I find it out the distance between these two, yes, this is right angle and I can write as this as an R square plus X square. So plus KQ divide by under root of R square plus X square. This is potential at point A. Yes. What did you assume? Tell me seriously. Did you do the same thing? Great. So now let's find out the potential at point B. Now a same thing would be happen that at point B there is a potential due to two charges. One of the charges plus Q, one of the charges plus Q. That for this charge, it's a second of charge. It's an KQ divided by R plus plus. Now due to this charge, you need to write down the potential. It is an KQ divided by root of R square plus X square. If I look at the potential at A and potential at B, then they both are of same value, and if they are of same value, this work done require would be a 0. Work done require would be a 0 to shift a charge from one location to another location. So and this kind of surfaces, when you need to transfer a charge from one point to another, and that work done required would be a 0. These surfaces are called as the equipotential surface. These are known as the equipotential surface. Yes, These are the equipotential surface. We will learn this in next 2 to 3 classes. But remember this name. It's an equipotential surfaces. Yes. Are you done with this? Are you sure? Are you sure? Yes. So let's wind it up here. We have gone through two different sources for which we are working for the potential. One is the potential due to electric dipole, and another is the potential due to charge ring. And for charge ring, we have discussed about the two different cases on its axis and on its center. And for electric dipole, we were discussing about on the axial position, on the axial position, and the second one were for the equatorial positions. So I hope these things are clear to you. So up till now we have gone through three different sources. In the last class we have done up about the point charge. In this class we have done with the dipole and charge ring. So please please go through class notes repeatedly, revise it as much as possible, and do as many questions as possible. Please do it, that will help us. I also request you to go through the unit 1, because unit 1 and unit 2, these two units will combinedly make an one concept, or we can say a one region of an physics that we call as an electrostatics. And in next class even we will require an formula of electric field due to sphere, due to point charge, due to hollow sphere, due to solid sphere, and all that. So please refer first unit as well, because if you no longer revise it, there are chances that you will forget those kind of things which we should carry out. So please revise unit number 1 as well as unit number 2. So let's sign off. Thank you. Bye bye. Have a good day. Take care.